Hi guys, how did you do at Simplex? It gets very frustrating and I know some of the numbers are a little bit horrible. Keep with it, it gets easier. So there are two different techniques of Simplex that I'm going to show you in the next few lessons. They're called the Big M and the two-stage. But I want you to just have a bit more practice at Simplex, and we're looking at what happens if you need an integer solution, because sometimes you will get an answer that's not a whole number and you'll need to adjust it. And I'm sure you know how to do it, but I thought if I do another lesson on it, it will give me another example of Simplex to show you, just to make sure that you have really got it. So this is question 1B. From the exercise I'm going to give you to try. We've got an objective function and I've got some constraints here. Now the first thing I need to do is obviously change these to equations. So I'm going to have to introduce my slack variables. So I'm going to use R for this one, and then I'll use an S for this one. Okay, and remember that we have to change our objective function so that it's equal to 0. Now I can put that into my Simplex tableau. Okay, so I've input that already. Notice that my basic variables here are R and S. So your slack variables again are the most basic. At the moment, we're taking R to be 10, S to be 8, which means X, Y, and Z are 0. So we're starting at the origin and saying that is one of our feasible solutions, which it would be. So let's go through the Simplex method again. We look down the column to see which is the most negative. This is the most negative, so this is going to be our pivot column. So this is going to be our pivot column. Oh, I can't quite fit a T on there, so there we go, pivot column. We need to work out theta. So we've got our value divided by the entry in that column. Now this one I'll be dividing by 0, which isn't actually possible. So 10 divided by 0 is not applicable, so I can't use that one anyway. This one would be 8 divided by 3. So I'm going to have to go for this one as my pivot row. So this in here, that's my pivot element. So I am wanting that value there to become 1. I want that Y to be 1. And I will then make the other elements in that column 0. So I'm making sure that Y is eliminated from the other equations and I'm only left with 1Y here. So in order to do that, I will want to take my, I'm going to use a different colour by the way, just so this kind of stands out. I'm going to take this row here, okay, because that's the pivot element. I'm going to take row 2 and I'm going to divide it all by 3. So that becomes 1, that becomes 4/3, and already I'm disliking my numbers. That's negative 4/3, 0, 1/3 and 8/3. So that's row 2 divided by 3. And because I've replaced S with Y, I'm going to put Y in there instead. That's still R and that's still P. Okay. Now remember, the idea here is to make this and this go to 0. So happily, that's already 0, so I don't have to do anything to my row 1. I can just copy it back out. So thank goodness for small mercies, eh? So there's my first row. My third row, I've got minus 12, but I want 0. So I'm going to have to add on 12 lots of 1 to make that go to 0. So my third column is going to be row 3 plus 12 lots of row 2. So minus 12 plus 12 lots of 1 does take me to 0. I've got minus 10 here, and I'm adding on 12 lots of 4/3. That takes me to a 6. Hi guys, I hope you're well, and I do hope you enjoyed Simplex Tableau. I know it's a little bit challenging and it can get a little bit fiddly with all the numbers. So I thought rather than move on to the 2 different types of Simplex Tableau, we'd have a bit more practice at this first. So we're going to be looking at what happens if you need an integer solution. And then next lesson we'll start looking at 2 techniques for when you have a problem that isn't less than or equal to. Because you must have noticed so far all the inequalities we've done are for less than or equal to. Well, what happens if they're greater than? So we've got 2 techniques for that. But we'll have a little look at another example today. This is from exercise 7C on page 197. I thought I'd look at 1B with you, and then that leaves you with 2 questions to try. So let's recap what we have to do. We've got an objective function here, and we've got 2 constraints. We have to rewrite these first as equations before we can enter them into our tableau. So let's rearrange our objective function and put that equal to 0. Brilliant. Our constraints, we're going to have to introduce a slack variable to both of these because they are less than or equal to. So to make them equations, we need a variable to take up that slack. So let's use R and S. Right, I'll put those into a tableau. Not the neatest one, I know. And let's have a go at the Simplex algorithm. So let's recap the steps. We look for the most negative value in the objective row. Well, it's going to be here. So we've got ourselves a pivot column. So we're going to be investigating what happens if we change one of these variables for y. So at the moment we've got a solution where r is 10, s is 8 and x, y and z are all 0. We're now going to replace one of these with y. So we're investigating a different vertex and see if that gives us a better profit. So let's work out our theta here. So this one would be not applicable because we're dividing 10 by 0. Here we're dividing 8 by 3. So we've figured out that this is going to be our pivot row. We've got our pivot element. So quick recap, the idea here is that this is going to go to 1 and we're going to eliminate y in the other equations. So using row operations, this is going to go to 1. These are going to go to 0. So I'm going to take all of row 2 and I'm going to divide that row 2 by 3. So row 2 divided by 3 will ensure that this value here, our pivot element, let me just circle it so you can remember, our pivot element is going to go to 1. So I'm taking all of that second row and I'm dividing it by 3. And I'm also going to take this opportunity to replace my s with y. 4/3, 1, minus 4/3, 0, 1/3 and 8/3. Brilliant, beautiful numbers here. Okay, that's going to stay at R and that's going to stay as P. Now, let me just fill these in because I should have done it earlier and I forgot. Okay, theta or row ops. Let's have a little look. This is already naught, so I don't have to do anything to row 1, so thank goodness. Little small mercies here to make my life easier. Right, not so easy down here. I've got to go from minus 12 to naught, so I'm going to have to add on 12 lots of this row 2. Okay, so row 3, I'm going to add on 12 lots of row 2. So that one becomes naught. Minus 10 plus 12 lots of 4/3 gives me 6. I'm just going to fill in the others, and then if you want to take a moment to check my workings, I'm pretty sure they're correct. I've gone through it a couple of times. I've used the calculator as well because I didn't really like dealing with these 4/3 and 8/3, but I'm pretty sure they're correct. But please take a moment to check. Okay, so we're in a situation here where we still got a negative value in your pivot row, so it's not optimum. We can read off a solution. We've got a feasible solution. R equals 10, Y equals 8/3. It is not optimal, so we need to keep going. So we've got a pivot column here, and we'd have to work out our pivot row. Okay, so moving to my next slide, I've copied the table across. To work out my pivot row, so I said this was my pivot column. Remember, we're going to work out our theta. So 10 divided by 2, this one is not applicable because if I work it out, I've got a negative number here. It's the smallest non-negative theta. Okay, so this is going to be my pivot row. My pivot element is 2. So very quickly, I'm just going to fill those in again. Theta or row ops. Lovely. Apologies for the writing. And you'll notice my Z is going to replace my R. So Z, Y and P. I want all of row 1 to divide by 2. Row 1 divided by 2. This will allow this to go to 1, and then I will turn those into naught. So I want to eliminate Z in the other equations. So I've got a half, naught, 1, a half, naught, and 5. And I want to get minus 4/3 to naught, so I'm going to have to add on 4/3 of row 1. So R2 plus 4/3 of row 1. I'll fill these in, and again, if you maybe just pause the video or something and then check that you agree with me on a calculator, that would be great. Row 3 is negative 24. I want to go to naught, so I'm going to have to add on 24 lots of that. So row 3 plus 24 lots of row 1. Again, pause the video if you want to just check my calculations here. But happy days, I've got no negatives in here. So that means I've got a solution. I've got an optimal solution here. Perfect. I don't have to go any further. Optimal solution. In my basic variable column, I have a Z with a value of 5. I have a Y with a value of 28/3. This makes all the other variables 0 because they don't appear in the basic variable column. And this gives me a profit of 216. Lovely. And remember, if they asked you in the exam, how do you know there's no further iterations of the tableau? How do you know you've got an optimal solution? You can say that these values are negative, or again, you can write out the objective row where you have your 18x and your 12r and your 12s, and you could show that if you increase those at all, it would actually cause your profit to decrease. Now, if we look at this, if we're talking about boxes of chocolate here, or people, or number of balloons, or flowers, we can't have 28 thirds. So this is an issue here. We have to find which integer closest to 28 thirds actually works. We're quite lucky in that this is an integer and we haven't got to consider loads of points here. So I've actually only got 2 points to consider. X is 0 in both of them and Z is 5 in both of them. 28 thirds is 9.3 recurring, so Y is either going to be 9 or 10. But I need to check that they don't fall into the non-feasible region. They might be in the shaded region where it's not possible. So I've taken my 2 constraints and I'm going to check what my values are. So if I put 0, 9 and 5 in, I get 0 plus 10 is less than or equal to 10. That works. If I put 0, 10 and 5 in, that one works as well. Okay, let's try the second constraint. 0 plus 27 take 20 is less than or equal to 8. Well, yes, it is. 0 plus 30 take 20 take away 8. That one doesn't work. So I've just plugged my x's, y's and z's into each of these and seen if they satisfied the constraints. They do here, they don't here. So this one actually falls outside of the feasible region. So our solution is going to be x equals 0, y equals 9 and z equals 5. Now going back to the objective function, if you plug your x, y and z into there, so all the way back here, if you plug your x, y and z into here, that will give you a profit of 148. If both of these worked, you would plug 0, 10 and 5 in as well, and you would choose a solution which gave you the maximum profit, and it obviously would be that one if it was feasible. I hope that helps a little bit and explains Simplex in a bit more detail. Before we look at the 2 methods which are going to allow us to deal with greater than or equal to constraints, which are called the big M and 2-stage, I want you to just have a little bit more practice on Simplex and doing what I've done on this page where I've looked at choosing the integers. So I've already done 1B. I'd like you to try 1A. You will have to draw out the tableau, hopefully not too many. And in question 2, you've got a real exam style question. It's worth 40 marks. You only have to do the tableau once, but there's a load more where you have to formulate the problem, you have to explain things, you have to show your understanding. Just a really good question. If you've got any problems with it, please let me know, send me photos, send me questions, and I'll do my best to make sure I can explain it to you. Okay, take care, best of luck, see you soon, bye.